like with combinations and permutations and things like that, okay? So today we're going to talk about just some general concepts of probability, and then we will move on to binomial probability, which binomial probability has like only 2 different outcomes possible. So let's just kind of first of all give some probabilities. If I said, what's the probability of when you flip a coin once of getting heads, what would you tell me? Yeah, 50% or 1/2, right? What's the probability of drawing a queen out of a deck of cards?
What is that?
How many queens are there? 4 out of 52, which you could reduce, okay? What about, how about this? What if I said rolling a sum, this one's different, rolling a sum of 4 on a roll when you're rolling 2 dice? Let's say they're different, like they're different colors. Okay, so let's talk about that a minute. How many outcomes are possible on the first die? 6. How many on the second? 6. So would you agree that when I roll 2 dice, think multiplication counting principle, there are 6 times 6 or 36 possible outcomes then? And like I said, we're going to assume that we can tell the difference between the 2 dice, that one, like maybe one is one color and the other is another. All right, so if I said, what's the probability of rolling a, what did I say, a sum of 4? What I would have to do is count the ways that that could happen. So on the first one, if I rolled and I got a 1 on the first die, then I could get a 3, right? So 1 and 3. 2 and 2. Now on those, would you really be able to tell the difference? No. Okay, 3 and 1. Is that it? That's it, isn't it? How many did I find? 3. So my probability of rolling a sum of 4 is 3 out of 36, which probability you can leave as decimals or fractions or percentages. 3 out of 36 is what? 1/12. Okay, so we should talk about then just in general what probability or the definition of probability is, and then we'll just do a couple examples. So here's our definition. The probability of an event, and what I'm assuming here is this is an event just due to chance. We're talking about it's not a weighted die, or it's, you know, it's something where the outcomes are just being counted. All right, so if I want to find the probability of an event, then the way that I write that in shorthand notation is we're going to use like P of E. What we are going to do is we're going to take the number of outcomes possible of the event and we're going to divide it by the number of outcomes in the sample space. And if you don't know what that word sample space is, after you write this down, we'll talk about that. Okay, so let's, just in case you don't know what sample space is, it would be the set of all possible outcomes of a whole experiment. Okay, so before I figure this out or start doing some things with probability, what is the probability never going to be greater than? 1. A probability of 1 means 100% that it is going to happen. I mean, not necessarily. You probably talk about theoretical probability and actual probability. Do you talk about that at all in stats or not? Like what actually happens and what should happen? Okay. And so what I mean is, though, if I get that something has a probability of 1, it's going to happen 100% of the time. If something has a probability of 0, that means it's not going to happen. Okay, but in general, the probability of an event should be between 0 and 1. It wouldn't go over those things. Okay, and then the second thing you should know is that the sum of all probabilities of an event should equal 1. Okay. Let's take the deck of cards, for instance. In a deck of cards, the sample space is all of the cards. So how many things are in the sample space? 52. Okay. If I wanted to add up, then let's say I was dividing the cards by suit. By suit, that would mean hearts, diamonds, clubs, what am I forgetting? Spades. Okay. Would you agree then if I said, hey, what is the probability you reach into the deck and the card that you pull out is a club? What's that going to be? Think just logically. How many suits are there? 4, right? Isn't it just going to be 1/4? Technically, what's really happening is you're dividing the 52 cards into 4. What is 52 divided by 4? 13. Okay, really there's 13 clubs total out of 52. So really what we're doing is 13 out of 52, but what it reduces to is 1/4. But if I would do the sum of all the possibilities of the event, well, that would mean if I would add what's the probability of hearts, getting a heart would be 1/4, right? The probability of getting a club would be 1/4. The probability of getting spade would be 1/4. The probability of getting a diamond would be 1/4. If I added those all up, what would they equal? 1. So an entire probability distribution should add up to exactly 1, not approximately exactly 1, in order for it to be valid. Okay, how are we doing so far? Good. All right, so let's talk about how we can use multiplication counting principle then with this. And to do this example, what I'm going to do is I am going to say I have a bag of Skittles. I'm probably violating some kind of like trademark thing, but okay. Bag of Skittles, because I really can't, like, I'm recording this. going to go on public. Maybe I'm going to get sued by Skittles for using them as an example. Probably not. They're too busy. Let's say in my bag of Skittles, just for the heck of it,